We'll proceed in pseudo calculus problems. Okay, so we are pursuing discussion in pseudo calculus problem, and many times we have kind of demonstrated. Many times we have demonstrated that integral calculus is nothing but simple multiplication only. If someone is proceeding in multiplication, he can convert multiplication into integral calculus. Okay, any multiplication can be converted into integral calculus. Yes, any multiplication can be converted into integral calculus. Okay, all integral calculus are multiplication? No. Integral calculus is superset of multiplication. Okay, repeated addition can be represented through multiplication? True. But all addition are not multiplication. But all multiplication are addition. That is for sure. All multiplication are integral calculus. Okay, all multiplication are integral calculus. All integral calculus, I'm sorry, all integral calculus, if I compute anything through integral, too much confusion. Okay, multiplication is subset of addition. Multiplication is subset of integral calculus. If whatever is happening through multiplication, it can happen through integral calculus also. Whatever is happening through multiplication, it can happen through addition also. Reverse is not true. How reverse is not true? 5 plus 5 plus 5 plus 5 plus 5 20 times is 5 into 20. So a multiplication can be replaced by addition, that is also repeated summation. But 5 plus 2 plus 1 plus 0 or 5 plus 2 plus 1 cannot be substituted in multiplication, not possible. So all multiplication what we have can be represented as addition. But all multiplication can be represented as integral calculus. But all integral calculus cannot be represented in multiplication. What is 3 into 2? What is 3 into 2? Okay, that I can replace as 3 into x. 3 into x, where x equal to 2. That can be written as 3 dx. Now it is 3 into 2 got converted into 3 dx, where dx is a kind of demarcation claiming it will be solved through integral calculus way. It is not a straightforward multiplication. 5 into 2 is same as 5 into x. It is same as 5 into dx. What is d? D someone can place as a demarcation for integral calculus. Many people they attach dx as delta x, but that is not true. If it is coming through multiplication, then it is not true. That dx is anywhere not equal to delta x. D mark is given claiming it belongs to calculus. That's it. So 5 into dx, it is not complete because we don't know what is the span of x or what is the period of x, what is the interval of x. To specify, if I say 5 into x, what is your x? X is from 2 to 5, means you want 5 into 5 minus 2. Makes sense? X is from 2 to 5. Now I want 5 into x. 5 into 5 minus 2. 5 into 3 you want. Yes, I want 5 into 3. That can be written as 5 into x, where x is 2 to 5, or it can be written as 5 into dx, and integration side x is from 2 to 5, same thing. Okay, 5 dx is 5x 2 to 5, same thing. So any multiplication can be written as integral calculus. Not all integral calculus can be written as multiplication. What is 5 into x? Okay, 5x. X you can put anything, or 5 dx integration 0 to what is the whatever is the range of the x. That is true. Consider instead of 5 I say y into x, where y is function over x. That is y equal to x. X into x. X into x, if I talk in like 5 into x, if I had said, then it is can be solved through 5 into x can be solved through normal multiplication also. 5 into x, 5x. Instead of 5, if I have y, and y is function over x. So y equal to x. Now what is y into x or x into x? Then through multiplication it is x square. Many times I have demonstrated this. Through multiplication it is x square. Is it really x square? No. It is x square by 2. If x into x, the first x is replacing y and y is function over x, then in that fashion x into x is not x square. It is x square by 2. It will be better represented as x into dx, and then it is x square by 2. So x into dx is integral calculus. It cannot be represented through multiplication. X dx is not x into x, whereas 5 dx is 5 into x. So some of the integral calculus can be represented through multiplication, but not all. Similarly, if I say 5 plus 5 plus 5 plus 5 plus 10 times, then it can be replaced with multiplication, 5 into 10. But if I say 5 plus 5 plus 5 plus 4 plus 5 plus 5 plus 5, 10 times, 1 4 is there. Now it cannot be represented as 5 into 10. Not all addition can be represented through multiplication. But repeated addition, one corner case addition can be represented through multiplication. Okay, this is the one way. One way, this is the one way where one way, okay, so this is the one way through which it can be represented through integral calculus. Multiplication can be represented through integral calculus. This is the one way. What is second way? Second way is repeated addition can be represented through integral calculus. Obviously, repeated addition means multiplication, and multiplication can be represented as integral calculus. Okay, we are not saying exact thing. What are you not saying exact thing? Okay, what we are not saying exact thing is, consider I have x-axis and this is 0 and this is alpha. This is 0 and this is alpha on x-axis. This point is alpha comma 0 provided this vertical line is y-axis. Now I divide this 0 to alpha into n different parts. N different parts. Each part is not equal. So we have now this is delta x1, delta x2, delta x3, delta x4, delta xn, where if I add all they are non-overlapping. So I can write the addition of all delta x is summation sign, that is probably sigma sign, summation sign I equal to 1 to n, and then delta xi. If I add all delta x, it becomes alpha. Okay, if there is a non-overlapping periods are getting added, then this can be represented where n tends to infinity, I equal to 1 to n tends to infinity. So many parts I chopped it, and then delta xi. If I calculate the summation, then it will become a like dx, dx. I can write delta xi as dx. Dx is not delta x. People generally consider delta x. Now delta x, just write a dx. That is not true. D means it signifies integral calculus. That's it. D means not, it is delta. Okay. Del D D D delta also starts with D, I believe so. So anyway, it is not that. Anyway, delta xi can be written as dx now, and integration from 0 to alpha, because summation of full delta xi brings in alpha 1. Okay, this is then how it is not, but this cannot be represented through multiplication. Delta xi plus delta x1 plus delta x2 plus delta x3 plus delta xn cannot be written as delta x delta x delta x into n, delta xi any ith section into n. It cannot be written like that, because all delta are not same. All delta may be of different weight, but if we add it, then it becomes alpha. but still it can be represented as integration x equal to 1, integration integration x equal to 0 to alpha dx. Okay, so this is the, we are working in that fashion only. We had taken example of circle and circumference. One session we will take to do many things, because circle area we had calculated dp by d theta r, where that is the area of circle through the repeated summation. If I cut the circle into so many sections, and then in that way each section, one particular ith section if I take, and that ith section area, then it is 1 by 2 function over theta whole square d theta integration theta lower limit to higher limit. This is what we had calculated. And through the vector fundamental, through vector fundamental also we calculated the surface area of a circle, and it came as dp by d theta r magnitude, where p is position vector of any point on the circle. If I take a circle, okay, if I take a circle, if I take a circle, on this circle is on xy plane. This is x-axis and this is y-axis. This is x-axis, this is y-axis. This is origin. Or I can take this is x-axis and this is y-axis. This is origin. If I take this is origin, then I have to specify the circle in shifted way, like x minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. That is the equation of circle if origin is here. Earlier, if origin is here and circle is centered at the origin, then it will be x square plus y equal to a square. But if circle has shifted to this direction, how much shift had happened along x-axis? Consider shift has happened 1 by 2. Then the radius is 1 by 2. It can be now written as x minus 1 by 2 whole square plus y square equal to 1 by 2 whole square. Okay, or in radius and theta manner, this fall under equation r equal to cos theta, where radius is function over theta. Radius will always start at the origin only. If this is origin, the radius will start from here only. So radius never start, not always start at the center of the circle. If the circle is centered at 1 by 2.5, 1 by 2 comma 0, and this is the origin, then where is your radius? Not necessarily radius will here. Radius will typically start from the origin only. Means radius is like this. When angle is 0, then radius is like this. When angle is growing, radius starts shrinking, becoming smaller, 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 smaller. And when radius angle is 90 degree, radius came back to here. Radius is 0 now. If angle grow like this, then radius become negative, because r equal to cos theta. R is a function of theta. R cos theta 90 degree plus means negative. If radius is negative, any line that is going towards negative direction, I can make it positive if I reverse the direction of the line. Now it is positive. So even though angle is moving like this up to 90 degree and then proceeding up to 180 degree, but this radius is negative here. So let it proceed to 180 degree, but radius will be drawn in this direction to make it positive. So it will become a circle again, where the angle spans from 0 to 180 only. Angle that is 0 to 180 makes the circle, not required 360 degree. Okay, in that fashion r equal to cos theta. We saw that area of a circle ith, if I divide circle into many sections, the ith section what we see, that we will talk, because there are little bit more on it. So if I see the ith section of the circle, ith section if I divide, then we saw this is r1, this is r2, because as we move theta is changing and radius is also changing. This is r1, this is r2, and circumference fall like this. R2 can be smaller than R1. The circumference falls like this at 90 degree. That is the hypothesis. Then in that fashion, this length is R1. This angle is delta theta I of the ith section. R1 delta theta I into R2 by 2. 1 by 2 R2 R1 delta theta I. R2 and R1 are function over theta. It can be written as 1 by 2 function over theta into function over theta delta theta I, summation I equal to 1 to n. This can be written as 1 by 2 function over theta whole square delta theta I, summation I equal to 1 to n. This is a fit case to represent into the integral calculus. Why it is fit case? This is fit case anyway. Or if I bring into vector way to calculate the area, then we saw it is integration sign and then dp by d theta r, d of p, where p is position vector of any point on the circle. If I take any point on the circle at x comma y, and from origin if I draw a line like this, that is the position vector. Position vector. I'm not talking about x is on the circumference. I'm talking about x is anywhere on the circle. If this is the point x is there, then from origin if I draw a line, that is the position vector xi plus yj, or p vector, capital P vector. dp by d theta r magnitude, dp by d theta r will bring the vector again. dp by d theta r magnitude into d theta dr is the area computation that we saw through vector way, and then integration sign. dp by d theta r is dp by d theta cross dp by dr magnitude d theta dr, where dp by d theta, if I calculate, then r I have to keep constant. This is generally not mentioned in the book, that if I do dp by d theta, then I have to keep r constant, or if I do dp by dr, then I have to keep theta constant. Why? Okay, those things we will proceed anyway. But we learned that if I get the area of a circle through repeated summation, then ith section area, if I divide the circle into many area, divide the circle into many area, area number 1, area number 2, area number 3, area number I. If I write like this, then area, this is the angle theta from x axis, and this is delta theta I. Okay, in that fashion, this triangle area is 1 by 2 r square, or 1 by 2 r2 into r1 delta theta I, that will give this length. R1 into delta theta I will give the arc length. Now it is 1 by 2 function over theta, 1 by 2 r2 r1 delta theta I, 1 by 2 r1 r2 delta theta I. If I consider r1 and r2 are function over theta, then straightforward I can write 1 by 2 r square delta theta I, where I is function over theta. 1 by 2 function over theta whole square delta theta I, summation I equal to 1 to n. Okay, that can be written as integration and then 1 by 2 function over theta whole square d theta y. This is we will talk. Then we will come back to our stick example. Stick example we are taking, consider there are n number of sticks, or there are innumerable number of sticks. Each stick has length of 1 meter or 1 unit. Okay, I cut the stick from any point. This is the half of the stick. This is the stick, this is the half meter. I can cut here, or I can cut after this also, or at the middle also. If I cut in this fashion, if I make a cut here, then I take this longer part. This is the longer part. If I cut here, then I take this longer part. Whatever the longer part is there, I now accumulate it, or I just keep it. Okay, all longer part I keep it, shorter part I throw it away. Okay, if I cut after the half, then this is the longer part. First part is longer part. If I cut below the half, before the half, then this is the longer part. If I add all the longer part, what is the mean value of its length? That is the question mark. Prior to that, let's see how we calculate the area of the circle. 1 by 2 function over theta whole square delta theta I, where delta theta is I is the angle of the ith section. How this expression can be converted into integral calculus? Okay, to have that we have given example. This is a discrete value, digital value, non-continuous value, whatever someone can consider, where summation I equal to 1 to n, and then 1 by 2 function over theta delta theta I, where delta theta I is the angle of the ith section, function over theta. Okay, function over theta. If really someone computing whatever we are saying, then actual computation will come as 1 by 2 r2 into r1 delta theta I. R2 is function over theta plus delta theta I, and r1 is function over theta I. Makes sense? If this is x-axis and we are talking about this is the r1 and this is the ith section, then this angle is theta I, and this angle is delta theta I. In that fashion, this R1 is function over delta theta I, function over theta at angle delta theta I. Whereas R2 is function over theta, where theta is delta theta I plus delta theta I. The actual area is 1 by 2 function over theta I plus delta theta I, or function over theta, where theta is theta I plus delta theta I, into function over theta, where theta is theta I into delta theta I. That is the ith section. That is the ith section area. How we can convert into integral calculus? This is the discussion we are pursuing. Okay, now consider that this is x-axis. Hope x-axis should be bigger. Consider this is x-axis and this is the origin. This is origin and this is x-axis. Okay, consider there is a point here called alpha, and then here 0 to alpha, I divide it into alpha part. Makes sense? Consider alpha is 80, 80. Alpha is 80. Now I divide x-axis into 80 part. 80 part. One part of length 1, one part of length 1, one part of length 80 part I divide. Okay, now I can describe any ith part as delta xi. Now I can write this as the full length alpha as summation of I equal to 1 to 80. I equal to 1 to LT delta xi. Means if I keep adding delta xi 1 to 80, then it will become alpha. Makes sense? Okay, this is then can I how I can write into integral calculus? Can I write this as a dx, where x is 0 to 80? Certainly we can write like this. How we can write like this, that we will see. Now let's proceed. Consider that at every interval I have divided a 0 to alpha into alpha part. Now we have alpha intervals. One interval, two interval, three interval of width 1. Alpha intervals are there. In a particular interval, I have a vertical. I have a vertical. Everywhere there is a vertical. Each interval, there is a vertical line. There are alpha vertical line. Okay, consider if this is x-axis, consider this is y-axis. Now everywhere I have alpha interval. If alpha equal to 80, I have 80 intervals. In 80 intervals, I have 80 bars. If I have 80 bars in 80 interval, 80 bars in 80 interval, then this proves that what is the height of each bar. Consider the height. Consider the height of each bar. Okay, okay. Consider Consider, consider the height of each bar. Consider the height. Now we are talking about in every interval there is a bar. If in every interval there is a bar, then what is the height of each bar in every interval? Consider this is function of x, like y equal to x. I have a function called y equal to x. Means in the first bar, consider the x I am taking at the end. First section is 0 to 1. I am taking x as the end point, that is 1. So height of the bar is 1. 1 to 2, height of the bar is 2. But one bar will exist only once in one interval. Makes sense? I have 0 to alpha distance along x-axis. I divide it into alpha chop. If alpha is 80, I divide into 80 part. Each part is of length 1. In one part, there is a vertical line. This vertical line, how much it will be vertical, is function over x, and that function is x. Then in the first bar, that is first gap, that is 0 to 1, its height is 1. 1 to 2, height is 2. Between 40 and 41, height is 41. Now in that way, what is the summation of all the vertical bar? I can write it as summation sign I equal to 1 to alpha, because alpha times it has to add. And then vertical bar is a function over x. I can write fx, function over x. When function over x, function over x, where x equal to I. Makes sense? Summation I equal to 1 to alpha and then in the vertical bar I can write function over x, where at x equal to I. Now if I write in summation, it will be function over x, function at x equal to I, function at x equal to 1 plus function at x equal to 2 plus function at x equal to 3 plus function at x equal to alpha. Okay, now this summation can I convert into integration? Certainly. It will be same as integration x equal to x equal to 1, x equal to 1 or x equal to 0 to alpha fx dx. Summation sign I equal to 1 to alpha function over x at x equal to I. In the subscript, I write x equal to I. This can be converted into integration sign fx dx. How you are sure about it? Okay, I'm sure about it that integration is nothing but calculation of the area. If I have alpha number of vertical, then if I'm adding all the vertical, if I am saying fx dx, integration sign more or less where x is 0 to or 1 to alpha, we are actually x-axis is there, then fx will draw a graph where fx is equal to x, it will make a slant straight line. Then what is the area between 0 to alpha? X equal to 0 to alpha limit fx dx. That area is same as if I take one bar and multiply it with a 1. Then this is the area of the one particular slice out of alpha slices. I made alpha slices. Each slice area is whatever the bar height is into the slice width, that is 1. That is 1 and a height. So if I say summation I equal to 1 to alpha fx at x equal to I, if I keep adding all the x, this is same as if I write alpha summation I equal to 1 to alpha fx into delta x, fx x at I delta xi, where delta xi is constant 1. Okay, this gives me a hint that one summation, there are I summation, summation sign I equal to 1 to alpha, summation sign I equal to 1 to alpha fxi into delta xi, fxi delta xi. If I sum it, I will sum alpha times, alpha time I'll sum it. Each time if I sum, then I take the value of the I, that is f1 delta x1 plus f2 into delta x2 plus f3 into delta x3, where all delta x are non-overlapping. If I say f1 into delta x1, then f1 is the height and delta x1 is the width. More or less we are calculating a rectangle in the first slice. Second slice rectangle, third slice rectangle, fourth slice rectangle, alpha slice rectangle. If I add all the rectangle, more or less we are calculating the area of fx spanning from 1 to or 0 to alpha. Simple. Okay, now I can convert it. Makes sense? Consider that if I have 0 to alpha, this is x-axis, and we have 0 to alpha, instead of chopping it into alpha part, I am chopping into n part, where n tends to infinity, so many parts. Now in every part, I am drawing on vertical line. In every part, what is the addition of all the vertical? That is I equal to 1 to n fxi. That is the summation of all. Can I convert into integration? Certainly not. If you convert into integration, it will become infinite. Okay, but that is not infinite. That is should be come to alpha. No, but I want to convert into integration. You cannot. You can convert into integration if you provide you multiply it with delta xi. If you multiply with delta xi, then each chopping from 0 to alpha, if you make n chop, n consider alpha is 80, alpha is 80, but you chopped 800 times, n is 800, 800 times you chop. Now each has a width of delta xi. Delta xi may not be the same for all chop, but whatever the ith section delta xi, that is the width. Now consider that there is a, I take any ith part among the n chop, that width is delta xi. At that point, if I multiply with the vertical fxi, it will give me that region rectangle. If I add all the rectangle, then I get the full from 0 to alpha. So I summation I equal to 1 to n fxi delta xi can be converted into integration x equal to 0 to alpha fx dx. Now people think, oh, delta become d. That is not true. That is different thing. Anyway, now if I am calculating the area of the circle through summation I equal to 1 to n 1 by 2 function over theta whole square delta theta I, it can be converted into integration 1 by 2 f square function over theta whole square d theta. Anyway, I believe it is all right. Idea of the integral calculus is integral calculus calculate the area. If you give a small area, non-overlapping area, and you add it, that will convert it into integration. But if you just talk about the height in numerous height addition, that will not work. So if you talk about in numerous height, that is okay, but that height must be multiplied by. If you chop it more than alpha, if on x-axis it is 0 to alpha, but you are chopping into n part where each part where n is tends to infinity, 8,000 part you are bisecting, intersecting 8,000 part, 8,000 chops you are making. In that fashion, each height must be multiplied with the chop width. That will be much smaller than 1. So more or less area will be very small. Anyway, then if you add, then it gives a full area, that is fx dx. Anyway, we are in mode of calculation of the kind of, first we will see the discrete, then we will see the integration. What is discrete value we get? If consider this is unit length stick. If this is unit length stick, consider I am dividing into n part. This unit length stick, I am dividing into n part. Now, this is the section 1, section 2, section 3, section 4. Like that, I have the nth section. Now, there are nth section. Now, this is the section number n by 2. Consider n is even, or consider n is 4. Then this is first part, second part, half came. Then that is n by 2th part. Then third part and fourth part. Now divide into n part. Each part, what is the probability? Each part, what is the probability? We are trying to calculate the mean of the length. If I cut this stick into two parts, if I cut this stick into two parts, the part where I am cutting, it can be this side or this side of the half house. Okay. What is the mean value? Okay, what is the mean value? We have talked that also in a great strength. What is the mean value? Mean value, like consider this is a class, and in class there are 10 students. If there are 10 students, then 4 students, this is 0 to 100 marks. 4 students get 50 marks. Three students, they get 60 marks. 1 student gets 70 marks, and 2 students get 40 marks. What is the average mark of the class? Then it is 40 into 50. It is 40 plus 50 plus 50 plus 50 plus 50. I'm sorry, 2 students get 40 marks. 40 plus 40 plus 50 plus 50 plus 50 plus 50 plus 60 plus 60 plus 60 plus 70. Divide by 10. That is the average mark of the class. Or if I draw a bar chart, then I multiply 40 by 2, 40 into 2, 40 into 2 plus 50 into 4 plus 60 into 3 plus 70 into 1. What is 50, 40? They are distance from the origin. If this is the origin and this is x-axis, that is the marks axis, this is called density. The bar chart is called density. How much is the density? The density is 4. Line is, everywhere line is there, but here density is 4. 4 into 50 means that is the distance from the origin. Distance from the origin into the density. 4 into 50. 2 into 40. 3 plus into 7, 6, 60. 1 into 70 by number of a student. Or if I say the how many students among total students they get 50 marks, then it is 4 by 10, 3 by 10, 1 by 10, and then 2 by 10. Directly I can compute, no need to divide by anything. Then it is 40 mark into 2 by 10 plus 50 mark into 4 by 10 plus 60 mark into 3 by 10. That is the probability density. Earlier it was density, not the probability density. Now 70 marks into 1 by 10. Just multiply and add it, you get the average mark of the class. Similarly, if I'm trying to calculate the stick average length, what is the average marks of the class? Average mark, this is the marks axis and height is the density axis. I get average on the this axis only. This is exactly we want the stick only. Also, average length of the stick. Now consider that if I out of n section, this is not available in any of the book. Discrete way, what we are talking, analogous way or continuous way is solution is available in the book, but discrete way solution is not available in any of the book. Anyone can try. It's not there. Okay, now consider that I cut at any of the ith section where I is 1 to n. N part I made it, length is 1. Now n chop I make it, where I will go from one first section to nth section. Now I make a cut in I, where I is less than half. When I is less than half, then what is the distance from origin to here? That is, if I cut in the third section, that is the ith section, then the length is I by n. Makes sense? I by n. Third by how many sections we have made? Because total length is 1. I by n. I by n. If I cut, consider this. I I is less than n by 2. Means I make in the first half cut. If I make first half cut, then the length where I'm cutting, this length will be the stick length that I don't want to take. Consider I am cutting after the half. Then what is the I? I is from here only. So I is the actual length is I by n. And what is the probability density at this point? Means what is the probability that I'll cut at any place? All places probability is same. Cutting at any place probability is same. What is the probability? Okay, consider there is a dice, and I roll the dice. If I roll the dice, then it has 6 probability. Okay, 6, 1, 2, 3, 4, 5, 6. If I roll it, then getting any one is 1 by 6. Anything 1 by 6. Similarly, if there are n cut, get cutting at any one of the section, the probability is 1 by n because probability is same. So if I say the probability density, that is the height of this, if I draw a bar everywhere height is 1 by n. If I talk about the marks, then getting marks at 50 marks, probability density is 4 by 10. Out of 10 students, 4 students get 50 marks. But here probability of cutting in any section is same, that is 1 by n. 1 in n. There can be n places someone can cut. In that way, it is 1 by n. Now, if I cut after the half, then this side length is I by n into 1 by n. That is the net amount we get. Makes sense the way we calculated the marks. So we get the length here is I by n into 1 by n if I is greater than 1 by 2. If I is less than I is greater than n by 2, if I is less than n by 2, then I have to take this length, not this length, because bigger section I'll take. And then I make a cut anywhere, then the height, then it will be 1 minus I by n into 1 by n into 1 by n. Okay, I cannot add it. Now you can add it because I is different at both places. Now there are two cases. If I is greater than n by 2, the net length what of the stick what we are getting is I by n into 1 by n. If I is less than n by 2, then it is 1 minus I by n bracket into 1 by n. Okay, now someone calculate it where n tends to infinity. Okay, now we have two summation. One summation is I greater than n by 2. Then summation I equal to 1 to n. I equal to 1 to n. Okay, and then it is I by n into 1 by n plus. Now when I is less than n by 2, summation I equal to 1 to n and then 1 minus I by n bracket goes into 1 by n. If this one someone solves it, then it gives the net result. How we can convert it to integral calculus, that is second thing. Let's see that how we can convert it to integral calculus. We will take example in next succession probability. How I can convert into integral calculus? Okay, what it is? Now summation of I equal to n, I equal to n, and then it is I by n into 1 by n. Okay, I by n I can take x. Consider from origin it is x distance. Okay, then I can take it as x. So I by n is x distance. 1 by n, can I write as 1 by n or 1 by x dx? It cannot be converted into integral calculus. Okay, 1 by n is the height. If 1 by n is the height, then there should have been one expression as delta n, delta section. If I multiply the delta section also, delta section, then you can multiply because it is one say, no. We have divided unit length into n part, where each part has a length as 1 by n. There should have been some expression as 1 by n that is missing. So, or in better word, there should have been expression like function over theta into delta theta, or function over n or function over I into delta I, that is missing here. We cannot bring it to integral calculus. Okay, summation of I equal to 1 to n, I by n into y 1 by n, plus summation of I equal to 1 to n, 1 minus I by n bracket 1 by n, I cannot convert into integral calculus. How I can convert to integral calculus? We will see. We will take example. Let's take one example. Consider I chop into 4 parts. I chop into 4 parts. In that way, n equal to 4. Now, first is I have taken more than half, means third part and fourth part. If I take third part, then what is the distance from here to here? Then it is 3 by 4. Makes sense? I by n, I is 3. 3 by 4 into 1 by 4, that is constant 1 by n. 3 by 4 plus 3 by 4 into 1 by 4 plus 4 plus, I'm sorry, I equal to 1 to n by 2, half, half. And here also I equal to 1 to n by 2. Now it is 3 by 4 into 1 by 4. Then next section if I cut, then it is 4 by 4 into 1 by 4. It becomes 1 by 4 in bracket 3 by 4 plus 1 by 4. Make sense? This length is 3 by 4 into 1 by 4. And then this will become 3 by 16 plus 4 by 4 into 1 by 4. 4 by 16. It becomes 7 by 16. 7 by 16. Okay, all right. Let's proceed other direction. Now we have there again 1 minus I by n. Same thing, 3 by 4 only, because I am cutting this side. 1 by 4. 1 minus 1 by 4, 1 minus 2 by 4 will become same thing. 1 by first section and second section. 1 by 4, 3 by 4. And 1 minus another 2 by 4 will become 2 by 4. Okay, whatever it is, multiplied by 1 by 4. Okay, we'll try now. 1 minus I by n. 1 minus I is the 1. Then 1 minus 1 by 4, 3 by 4. Okay, next is I equal to 2. 1 minus 2 by 4, it will become 2 by 4. So 3 by 4 plus 2 by 4 into 1 by 4. Okay, in that fashion it will become 3 plus 2 by 16. That is 5, and this side 12. 12 by 16. 12 by 16 is the net result. Well, how much it is? 3 by 4. It is coming as 3 by 4. Someone can try, let's make n as 8. Let's make n as 16 and then try. The first summation, if I make n as 8, then it will come as fifth one, right? Fifth by 5 by 16 plus 6 by 16 plus 7 by 16 plus 8 by 16. That side 1 minus I by n. 1 minus 1 by 16. That will come as, I'm sorry, I have divided to 8 parts. Here it will 8 into 8, 64. Actually it will come as, I have divided to 8 parts. 8 into 8. I by n into 1 by n. Now it will come as 5 by 60, 64 plus 6 by 64 plus 7 by 64 plus 8 by 64. That side it will become 1 minus I by n into 1 by n. 1 minus I by n. I is 1, then it will become 8, 7. 8 minus 1, 7. 7 by 64. Then, then 6 by 64. Then 5 by 64 and 4 by 64. Someone has to add it. Okay, 4, 5, 6, 7 and 5, 6, 7, 8. More or less same only. Okay, someone add and divide by 64. We'll do it for this example. 8 plus 7, 15, plus 6, that is 21, plus 5, that is 26. And this side we have 7 plus 6, that will come as 13, plus 5, 18, plus 4, 22. 22 plus 26, it will come as 48. 48 by 64. Okay, that will come as 3 by 4. Again 3 by 4. Someone can try dividing into 16 parts. Okay, probably it will come as 3 by 4 again. So looks like the answer is 3 by 4. But problem is that through digital way, discrete way, we cannot go with the exact solution. We have to take integration. Why integration works is because n chop what we are taking, n tends to infinity in integration. Here 16, 16 chop, 32 chop, 1000 chop we can do. Infinite chop I cannot do. That's why integration is invaluable. Now consider I make infinite chop. Then you calculate the average length. That we will see how we can convert into integration, and then we see the result. Okay. This digital one is not available in any of the book. Please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. +91 is the India country code. 9483160610 is the telephone number.